Hello everyone, I am Vamshi from VC department. My AIT Tech Talk topic is about visible light communications based on CDMA technology. Abstract. VLC can perform the functions of communications and light simultaneously, which is expected to be an important part of next generation wireless communication compared to the traditional RF wireless communications. VLC offers many salient features such as its operations on unlicensed visible light spectra, its support of high communication rates, and its immunity against electromagnetic interferences. In this article, we focus on code division, multiple access to techniques used in VLC system, and discuss different application scenarios for VLC CDMA technologies. In particular, two types of VLC CDMA system will be identified, that is unipolar ports and bipolar ports based VLC CDMA systems, whose performances will be analyzed and compared explicitly. Introduction. With the rapid growth in the number of mobile devices, electromagnetic radio frequency spectrum has become a scarce resource. Recently, visible light communication has attracted much attention as an emerging wireless communication technology. VLC may use existing lightning infrastructures to realize the functions of lightning and communications simultaneously. In VLC systems, transmitters are implemented by LEDs which transmit information via the flickering of light on and off at a very high speed line of sight, and diffuse links compose the transmission channels of VLC systems. Receivers in VLC use photodetectors to receive data information from transmitted optical signals compared to traditional RF wireless communications. Available bandwidth in VLC is about 300 terahertz, which is far much wider than RF, and the license authorization process is not necessary for VLC. In addition, VLC is much more secure than RF communications, as the light used in VLC systems cannot penetrate non-transparent objects such as partition boards, walls, and so on. VLC uses totally different frequency bands from RF, and thus it does not produce electromagnetic interference to conventional RF wireless communication. In this sense, it can be widely used in hospitals, airports, and gas stations, which are susceptibility to electromagnetic interference or safety concerns. Moreover, VLC has the advantage of being harmless to humans compared to RF communications, and thus it can use a relatively high transmission power if necessary. System models. According to the signature codes used, there are two different types of VLC CDMA system, that is based on unipolar codes and those based on bipolar codes. For VLC CDMA system with unipolar codes, several important redesigns of ROC were reported in 2011, 2012, and 2015 respectively. An enhanced design of PC was proposed in 2013, and improvements for OOC and its combinations with the other codes appeared in 2014 and 15 respectively. The traditional bipolar codes were suggested to be changed to unipolar codes for the application of VLC CDMA systems in 2015. Discussions on bipolar codes began in 2009 with pulse width modulation, followed by system performance investigations in 2013, 2014, and 2015. Walsh-Hadamard sequences have been commonly used due to their ideal correlation functions in synchronous channels. In addition, gold codes and M sequences are used in VLC CDMA system. In this article, we focus mainly on the unipolar signature code used in VLC CDMA system, the performance of VLC CDMA using conventional bipolar codes, VLC CDMA system with unipolar codes. The unipolar codes of VLC CDMA system includes ROC 8, 10, 11, PC 9, OOC 3, 7, 12, zero cross correlation ZCC codes, and bipolar to unipolar BTU codes. A general structure of VLC CDMA system with unipolar codes is shown in figure 1. In the VLC CDMA system with different unipolar codes, modifications must be made with regard to modulation schemes, LED types, channel models, and receiver structures as shown in figure 1. The VLC CDMA system with the aforementioned 5 types of unipolar codes will be introduced respectively as follows. Random optical codes are suited for the application scenarios where a large number of users share the same channel, such as wireless sensor network. The correlation functions of ROC may not be optimal, but it can still be good enough to allow a large number of users to share common VLC channel. In a VLC CDMA system, each user is assigned to unique signature code. 1 bit duration T is divided into n chips, where n is the length of ROC only. W chips are actually transmitted non-zero power level, where W is called the code weight and the position of W non-zero chips appear randomly in n chips. Moreover, these code sequences transmit data only when the data bit is 1. A series of ROCs have been proposed so far, and one example its applications in audio experiment 8, 10, 11. To get more codes, cyclic shift can be used to modify the original ROC. Different shifts were assigned to different transmitters to avoid interference, and a receiver uses a shift register to perform matched filter operations to recover the transmitted signals. Prime codes have been commonly employed in non-coherent and wavelength hopping OCDMA systems due to its advantages of a simple code generation process and relatively easy design of the encoder decoder. However, the correlation function of PC are not optimal, and its autocorrelation side lobes are normally too large, making it difficult to achieve accurate synchronization for both transmitters and receivers. Thus, it is not suitable for asynchronous VLC CDMA system, and the improvements in PC were proposed accordingly. In generalized modified prime sequence codes, and inverted GMPSC were designed on the basis of modified prime sequence code. GMPS can be used in MUU cancellation systems by optimizing correlation functions. VLC CDMA system with bipolar codes. Bipolar codes, which have been widely used in wireless CDMA system, can be applied to VLC CDMA system as well. Most of the related works in the VLC CDMA focus on direct applications of bipolar codes as used in RF system. In this subsection, we will analyze the performance of VLC CDMA using different types of bipolar codes. We will start our discussion with Walsh-Hadamard sequence. Both autocorrelation and cross correlation of Walsh-Hadamard sequence are ideal, and thus it is easy to apply them to VLC CDMA. To the best of our knowledge, there are 5 related works concerning the direct applications of Walsh-Hadamard sequence in VLC CDMA system as detailed in the following. One example is the application of Walsh-Hadamard sequence in CDMA in VLC system. The IM or DD mechanism is used in the system, which is implemented based on the orthogonal frequency division multiples technique, and Walsh-Hadamard sequence were used as its signature codes for resource sharing in synchronous channels. Another example was illustrated, which was an experimental demonstration of VLC CDMA system as shown in figure 2, where only one LED array is depicted for illustration simplicity. In the experiment, 4 femtocells were operating simultaneously, and each user was assigned a unique orthogonal code for downlink transmission. Walsh-Hadamard sequence were used to guarantee orthogonality among different users and to eliminate intercell interference. Phase shift maximum length pseudo-noise sequence were used to distinguish different cells and to avoid intra-cell interference. Performance of VLC CDMA system with unipolar cores. Design issues of ROC were discussed extensively in 8,10,11, and the obtained ROCs were applied to some CDMA systems such as audio experiment systems in 8. The code length, code weight, the number of users, chip rate, and data transmission rate were 100, 10, 8, 1 megachips per second and 10 kb per second respectively. In 8, M was used to define the size of the permeable used to perform bit synchronization of a receiver with its corresponding receiver signal. Therefore, error-free communications can be achieved when M was made longer than 4. The discussion in 10 were quite similar to those in 8, but chip rate and data rate were 2 Mbps and 20 kb per second respectively. The BR performance was close to 2 into 10 minus 5, and SCR is 5 into 10 minus 6 when M is equal to 3 and 4. Performance of VLC CDMA system with bipolar codes. In this subsection, we will analyze the performance of VLC CDMA system with bipolar code, that is Walsh-Hadamard sequences and modified bipolar codes. For Walsh-Hadamard sequence, 5 related works have been discussed previously, and the system performance given in this work will be presented in the following. MC CDMA VLC. An MC CDMA system using Walsh-Hadamard sequence was proposed in 1. In the simulations given therein, the length of Walsh-Hadamard sequence was 32 and the maximum number of supported users was 32. When the same modulation scheme was used, the larger the data rate is, the fewer users the systems can support. At the same data rate, the higher order of modulation scheme is, the fewer users can be supported. PWM modulation in VLC. In 15, CDMA technology was used in VLC system with PWM modulation. The communication link was almost error-free within the range of 10.7, 9.3 and 8.1 meters for red, green and blue LEDs respectively, and the performance degraded with an increasing distance between the receiver and LED. The different error-free ranges for different colors results from different LED outputs, powers and different PD responsiveness properties. VLC with CSK and OAK. A CSK scheme was proposed and analyzed with the help of an experimental demonstrations in 5. Like in the experiment setup, transmitters were 4x4 RGB LED arrays. Transmission distance was 50 cm. Spreading factor of key OAK were compared in scenarios with 2 users. When BR reached 10-4 SNR values of a system using CSK and OAK were 9 dB and 12 dB respectively, indicating the performance of the CSK system was improved by 3 dB if compared to an OAK system. BR of the proposed CSK system can be made lower than 10-6 as shown in figure 5.